Hey, this video is going to cover chapter 3.1, which is looking at pairs of lines and pairs of angles. All right. So let's start off with the first four questions. We want to think of each segment in the diagram as part of a line. Which lines or planes containing point B appear to fit the description? Okay, so point B is right here. And then let's look at, there's three lines that kind of contain point B. We'll color that. So we have this line here, which we can call BG. And this line here, which we can call AB. And then we have this third line here, which we can call BC. Right, and so which of those three lines, there's a pink one, a blue one, and a green one. Let's start with number 3, right? So which of the three colored lines is parallel to the line FG? Right, so FG is right here, it runs left to right. Okay. So parallel lines are lines that are in the same plane, they are on the same surface, and they don't intersect, they don't cross. Okay. Well, we can see that the red line AB also goes left to right. It's in the same plane, it's on the top surface of this prism. And it doesn't appear like you would ever cross paths with FG. So we can say that line AB is parallel to FG. Okay. They're kind of running in the same direction and they would never cross. All right, let's look at, so let's make a note here. Parallel just means non-intersecting. Okay, but they have to be in the same plane. Okay, so lines on the same surface. I want to do question 2 next. So let's find a line that's perpendicular to FG. Okay. So perpendicular means that it meets at a right angle. At a 90-degree angle. Okay. So we can see here there's a little, the blue line meets up with FG, and there's a little square there in the corner telling us that that's a 90-degree angle. Okay. So the answer to number 2 is the line BG. And then we'll get to the skew line. So skew is not one that comes up too often. This means that it's two non-intersecting lines, but the lines are in different planes. So the lines are on different surfaces. Okay. Non-intersecting, different planes. Okay. So BC kind of runs in this diagonal direction. FG goes left to right. It does not appear that those two would ever meet, and they're also in different planes, right? FG is a line that's on the top plane, okay, and BC is not on the top plane. It's kind of on this side plane. Okay, so we'll write the line BC. The green one is skew to FG. And then we'll go to question 4. So now let's find some planes that are parallel to plane FGH. So let's color in FGH. So FGH is kind of the back side of the figure. So parallel planes are going to be non-intersecting planes. Okay, so planes that don't touch each other. Okay, so the only plane or side or surface here that does not touch FGH would be the front side. Okay, let's color this, right? So plane A, B, C, right? So the front plane and the back plane would never touch or cross. So we'll name it plane ABC. All right, The next questions have to do with parallel and perpendicular lines. So when we're looking for parallel lines, we're looking for little red arrows. So this was printed in black and white, so the arrows don't actually show up as red, but you can still see the little arrows. So there's a pair of single arrows here and a pair of double arrows there. So I'll just highlight the lines, right? So these two lines both contain a single arrow, so we know they're parallel. And these two lines both contain the double arrow, so we know they're parallel to each other. So we can write line WX is parallel to line YZ. Okay, and this is the symbol for parallel. It's just two vertical lines. Okay, and then our blue lines are also parallel, so that would be line VU is parallel to RQ. Right, now let's name a pair of perpendicular lines. Okay. So perpendicular lines you can locate because there'll be a little red square where they intersect. Okay, and that square means that it's a 90-degree angle. Okay. There's only one of these symbols in the diagram, and so that symbol is where the line ST and UV intersect. Okay, so ST is perpendicular to UV. Okay, and that's the symbol for perpendicular. It's an upside down T symbol. Let's look at number 7. Actually, it's got a lot going on here. I'm going to switch over to a fresh sheet. Okay, so we're on question 7. Is WX parallel to QR? Okay, so WX is right here, and QR is right there. Okay, so are those two lines parallel? Well, clearly they are not. And we can tell because they intersect, right? Parallel lines don't intersect each other. Those two lines do intersect. Okay, so not parallel because they intersect. Right, and then question 8, let's get a fresh sheet again. Okay, so is the line ST perpendicular to NV? Okay, so ST is that line there. NV, there's N and V, is that line there. And we can see that where those two lines intersect, we see that square symbol. So that tells us, yes, they are perpendicular. Okay, because we know they meet at a right angle. Okay. All right, so questions 9 through 12 is asking us to identify special pairs of angles. So we've got corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Now, this diagram is a little complex. There's like 12 angles altogether. I'm just going to simplify the problem and let's just look at the first 8 angles. All right, so we're just going to look at those angles right there. Okay, so first what I want to do is I want to identify my transversal. Okay, the transversal is the line. So there's 3 lines, right? The transversal is the line that intersects the other 2. Okay, so my transversal is this line right here. Okay, I'm going to put a T. next to it, right? Just identifying it as the transversal. Right. So let's start with corresponding angles. Okay. Corresponding angles are angles that are in the same relative position, right? Notice that the angles come in groups of 4, right? We have 4 angles all around that point and 4 angles all around that point. Okay. So we can kind of pair these four angles up based on their relative position. Right. So for instance, angle 1 is kind of in the lower left position here. And angle 5, we would also say is in the lower left position. Okay. So we could say angles 1 and angle 5 are corresponding. Okay. Angle 2 is in kind of the top left position, and over here angle 6 is in the top left position. So those two angles have the same relative position. So angle 2 and angle 6. Angle 3 is in the lower right position. Angle 7 is also in the lower right position, so those are corresponding. Angle 3 and angle 7. And then finally we've got angle 4, which is in the top right position, and angle 8, which is in the top right position. Angle 4 and angle 8. So those are corresponding angles, right? Angles that are in the same relative position. All right. Next, let's look at alternate interior angles. And I'm going to have to switch to a clean sheet here. So alternate interior, actually, let's identify the transversal. That's our transversal. Okay. So interior means that these angles are within the two lines. Okay. Normally it's parallel lines, but I understand that in this case there are no parallel lines. Maybe we should start with the word alternate. Okay. Alternate means opposite sides of the transversal. Okay. And then interior means on the inside. Okay. So we could say angles 5 and 4 make up an alternate interior pair, right? They're on opposite sides of the transversal, and they're inside the other two lines. Okay, so angles 5 and angle 4. There's another pair of alternate interior angles, and that would be angle 2 with angle 7, right? 2 and 7 are on opposite sides of the transversal line, but they're inside the other two lines. Angle 2 and angle 7, alternate interior. Let's move on to alternate exterior. So again, the word alternate just means opposite sides of the transversal. So there's our transversal. And then exterior means angles that are on the outside of the figure. So one pair of alternate exterior angles would be angle 6 with angle 3, right? 6 and 3 are on opposite sides of the transversal, but they're also on the outside of the figure. Okay, angle 6 and angle 3. Okay. There's another pair of alternate exterior angles, and that would be angle 1 and angle 8. Okay. Angle 1 is on the left side of the transversal, angle 8 is on the right side, and they're both on the outside of the figure. Angle 1 and angle 8. Finally, we're going to take a look at consecutive interior angles. label the transversal. Okay, so in this case, consecutive means same side of the transversal. And then interior just means on the inside of the figure, as opposed to the outside. Okay. So let's see if we can find two angles that are on the same side of the transversal, either both on the left or both on the right, but also on the inner part of the figure. Okay. So angles 5 and 2 are both on the same side of the transversal, the left side, and they're both on the interior inside part of the figure. Okay. Angle 5 and angle 2. And then we can also say that angles 4 and 7 are consecutive interior. These are both on the right side of the transversal and again on the inner part of the figure. Angle 4 and angle 7. So those are the 4 different angle pairs that you need to know. These all have to do with 2 lines that are intersected by a transversal line. Okay. Earlier we looked at parallel and perpendicular lines, and then we kind of looked at parallel, perpendicular, and skew lines at the beginning. Again, skew is not terribly important because we often don't deal a whole lot with 3-dimensional figures. We're mostly dealing with 2-dimensional figures. And so we only really focus on parallel and perpendicular most of the time.